Hello, I'm Hương Nguyễn from University of Oulu, and today I will present how to build a machine learning workflow and make it run on Kubeflow. So we are trying to train a tiny YOLO version 3 model on our custom dataset. So to do that, the whole process would be, first we need to upload our data into some data repository. In here we have the LakeFS. Here, yes, this is our data. And the second one, we need to design the pipeline. So we create the two-stage pipeline, the train and predict operator. So in the training part, we just need to download all the data from LakeFS and we fed it into the darknet to train the YOLO model. And after we get the model trained, we just need to save it into the MLflow server for later use in the prediction operator. And one thing is we may need to upload the container to Harbor. So the Harbor in here is due to catch the container instantiation process. So using the Harbor in here may make the container creation step faster somehow. But more important is we need to create the experiment in Kubeflow and make it run. We also provide here some Python script to access the LakeFS repo and also the MLflow server. So for LakeFS, you just need to create the client. You can do it using the LakeFS client library in Python and use this API, getObjects API, to retrieve the data. And for MLflow, it will be easier and much simpler when you just need to provide the MLflow server and you just need to use the log artifact API to save or log all of the things that you want to the server, and also use the download artifact to download the thing that you want. Okay, and as I mentioned earlier, so we have the two-stage pipeline, the training and prediction operator. So you can see here we define the prediction operator needs to be run after the training operator. And we also make user to have ability to customize many parameters for the training here. All of the Python code is not directly compiled and run on the Kubeflow server, so we need to parse it into the YAM file first to run it, to make it runnable on the Kubeflow. So to do that, we need to have the KFP, which is the Kubeflow pipeline SDK. It is very easy to install with pip from Python. So after we get the YAM file, we can easily run it with the Kubeflow. This. Okay, so on the left here is the illustration for the whole process that I just mentioned earlier in the very first slide, and on the right side you can see that the code and the config instruction are available. I already pushed all of the code for training the tiny YOLO on GitHub, and you can use this QR code to directly access it here. Okay, so for the demo, you just need to, so first you need to, when you access the Kubeflow, it will go to the home page, but you need to go to the notebook and you click to connect. It will take some time to go, so I already opened this before. So you create the pipeline here, pipeline.pip here, which is pretty same with this one. Please take some time to do that. So go here to prepare for creating the pipeline. Okay, so you see the pipeline YAM file is here, so you need to download it to your local machine, and then you create the pipeline, upload the pipeline, something like uc4. Upload the pipeline to see, upload this one. Yes, to create an experiment, something like uc4 x. That's all, and then create a pipeline, uc4, create run, choose the experiment uc4. Yeah, so in here you just need to paste all of the thing here, the config file. Okay, so just click start. Okay, so after some time, you just need to click on this and check out the log. So you see here, it's already trained. Yeah, so this will be the iterator, the loss, and the average loss. Yeah, so basically something like this. After this, you will also see some of the example for training. So you see the iterator 290 loss, average loss, and yeah, you see the later iterator will have this much smaller loss value compared to the early one. So in here you will see the prediction output, the example of the prediction output from the model. And yes, it's all from our side. Thank you very much for listening. Yes.